How's it, everybody, and welcome to another one of James's videos. Today we're going to move on to type 2 of your trigonometry for grade 11 special angles and reductions. Okay, so from the previous type, we obviously had variable acute angles, whereas this one we are now going to have actual acute angles for every single one of these reductions. So what we're going to start off by doing is we are going to start by reducing all of these into acute angles. Now, remember, reductions is dealing with making really big angles that are in between 0 and 360 and making them acute angles. Okay, so knowledge that's needed to be had here: you need to know your cast diagram and you need to know your special angles. Okay, so let's jump straight into it, shall we? So the first one is tan of 210. So the first thing we ask ourselves, what quadrant is 210 in? 210 is in the third quadrant, which is known as the 180 plus theta quadrant. So we're going to say tan, we're going to reduce it first, or not reduce it, we're just going to change it into a setup or a format that we can reduce it. So 180 plus what gives me 210? 30. Okay, then your next step, okay, so that one's done. So let's move on to the next trig function. So sine of 240 degrees. 240 degrees, everybody, is in which quadrant? That is also in the third quadrant, which is the 180 plus quadrant. So we're going to say 180 plus what gives me 240? 60 degrees. Okay, great. So that one's also done. So let's move on to the next one. Sine of 170. 170 is in which quadrant? It's in the second quadrant, which is known as the 180 minus theta quadrant. So we're going to say sine of 180 minus 10 degrees. Okay, that one's looking a bit weird because obviously it's not giving me a special angle, but we will see how that cancels out later. So let's put a line underneath that for our fraction. Now we go into the cos 135. 135 is in which quadrant? The second quadrant, which is known as the 180 minus quadrant. 180 minus what gives me 135? 45. Lekker, that one's looking nice because it's a special angle. The next one is sine of 225. So we're going to say, what quadrant is 225 in? That is in the third quadrant, which is known as the 180 plus quadrant. So 180 plus what gives me 225? 45. Great. And then last one, cos of 100. 100 is in which quadrant? Second quadrant, which is known as the 180 minus quadrant. 180 minus what gives me 100? 80. Okay. Fantastic. Getting some degree signs here. Okay, now, once that step is finished, we can then go to the actual reducing stage. So now let's reduce these into their acute angles. Now, the first one, tan of 180 plus 30. 180 plus is the tan quadrant. Therefore, tan would be reduced to a positive tan of the acute angle, which is 30. Okay. Let's go to the next one. Sine of 180 plus 60. 180 plus is the tan quadrant, and sine is negative in that quadrant, so it would reduce to a minus sine of 60. The last one, sine of 180 minus 10. 180 minus is the sine quadrant, so it would reduce to a positive sine of 10 degrees. Okay, great. The bottom, cos of 180 minus 45. 180 minus is the second quadrant, which is the sine quadrant. Therefore, cos is negative there. So this will reduce into a minus cos 45. The middle one at the bottom, sine of 180 plus 45. 180 plus is the third quadrant, which is the tan quadrant. This reduces into minus sine of 45. And then the last one at the bottom, cos of 180 minus. 180 minus is the second quadrant. Therefore, it's negative cos. Okay, because cos is negative in the second quadrant. Fantastic. Now that we've reduced everything into acute angles, notice that all my angles are acute. And that is the whole goal of reductions, everybody, is to make them into acute angles so that we can solve for it further. Now, we can go ahead and cancel some stuff here. So a nice little trick is these two. When you have sine and cos on the top and the bottom of a fraction and their angles add up to 90, it means that they are co-ratios. And you can do the little test in your calculator and pause the video when you are doing it. But what you can do is if you put sine of 10 into your calculator and you put cos of 80 into your calculator, the answers are exactly the same. And why is that? It's because they are co-ratios of each other. So if you have sine and cos at the top and the bottom of your fraction and their angles add up to 90, they're complementary, then it means that they are exactly the same thing. So I can cancel them out. Another way of doing it is you can change the sine of 10 into cos of 80. Then you're canceling out the same thing. But what I want you guys to get to know is that when you have sine and cos on the top and the bottom of a fraction and their angles add up to 90, you can cancel them because they are co-ratios. They are exactly the same. Okay, it's just saving time and saving steps than changing either the sine of 10 into cos 80 or changing the cos of 80 into sine of 10 and then cancelling. Okay, but they are the same thing. Fantastic. And also, remember I told you there was a little bit of a red flag here with the 10 and the 80. Those aren't special angles. So how am I going to get rid of them when I do my simplification? 9 times out of 10, guys, you will get if you get a 10 here, you kind of can already predict, okay, there's going to be a co-ratio scenario, which means that I need to get a cos 80 at the bottom in order to cancel it, or another sine of 10, which is the same thing. Okay, fantastic. Now the other ones, we are going to use our special triangles or special angles. Okay, so we know 45, 45, we know 1, 1, root 2, and we know that this is 30, 60, 1, 2, root 3. Okay, so let's go ahead. Tan of 30, opposite over adjacent, that would be 1 over root 3. Sine of 60 is minus root 3 over 2, all over minus 1 over root 2 times minus 1 over root 2. Okay, so let's simplify this further. We don't need calculators, so we can go ahead. Because we're timesing here, these would end up cancelling. So at the top, we're left with minus a half, and at the bottom, minus times a minus, those will cancel. They'll give me a positive, and then 1 times 1 is 1, root 2 times root 2 is 2. So now I've got minus a half over a half, and that is going to give me minus 1 as an answer. What a lovely answer from really, really big, complicated question. Okay, so everyone, fraction simplification is needed here. Let's exercise those math brain cells and not resort to calculators, because at the end of the day, a lot of people struggle with fractions and they freak out when they see fractions, and we don't want that. So exercise those math brains, try and do it manually, and use your calculator as a checking tool. Okay, great. I think that's it. I hope you guys enjoyed that video. If you want to see more, please click the subscribe button, and you'll be alerted when there's new videos being uploaded. And also, all these notes are available in the James book, which is for sale. So please, if you are wanting to purchase it, make a comment in the comment section so that we can get in contact with you, or you can contact us directly and we will make sure that you can get a copy. Great. Have a good day.